we've loaded the bases for you. So batting cleanup for us this morning is Jeff Wade. We've talked a lot about solid wood material. Now we have an opportunity to talk about some of our byproducts and an excellent way to convert some of the material that you're producing every day now that's become more of a challenge to get rid of, that Southwest Virginia BioChar has come up with. Jeff is in Floyd, Virginia. He has a production facility that's already underway making a carbon product that has a tremendous opportunity, a lot of markets coming up. So he's betting cleanup for us, going to clean it up and talk a little bit about biochar and some advances they've made in that industry and opportunities for you as manufacturers to sell him materials. Jeff? Forward, bottom button's back, and then you need to point in.
Well, good morning. Thank you for allowing me to be here. I appreciate Appalachian Hardwoods allowing me to be here and present what we're doing. We are SWVA BioChar, which is short for Southwest Virginia BioChar. We have a partner. We already have a plant in Colorado that is up and operational. We are semi-operational now. We have been making some carbon. We're waiting for our processing line to be completed. We're actually building all that ourselves. And so we're really excited about what's going on and where we're moving forward to. So this is a little bit about our company. We did start in 2021. My partner out of Colorado developed this technology back in 2011. So we're a new franchise, I guess you would say, a biochar now. My partner is James Gaspard, and I also have another partner of Jack Wall. That is, all three of us own this company together. Our goals is obviously to create a product out of a waste product. We can make carbon, which is with everybody knowing with the climate change and with whether you believe in it or not, but we're seeing a lot more activists working toward the lumber industry to not cut down trees. Sequestering carbon through simply leaving trees is not the way that we want to go. We've got to find a common ground with these type of people, because you guys are in this business and you're just not going to quit. And I'm not against any activists in the environment. I'm for them. I want to help in any way we can, but we got to find common grounds to work with one another, that we can move forward in this industry, that everybody can benefit. And that's a little bit of the way I am. I like to find common grounds. So this product that we're making, and it's just amazing how that the Lord has designed our earth to be self-sufficient. And the products that you are making and using, how that we can take that and put that back into the ground and into multiple different types of applications and be able to create a really environmentally friendly product. What is biochar? And I won't read through all this for the sake of time, but it is highly absorbent. Basically, we take this wood, scrap wood, and we heat it at high temperatures, and we create a really absorbent product. Of course, you can read there about it, but it can be used in a lot of different applications. It's somewhat like charcoal. The only difference in our product is we are 100% organic. And in today's market, you guys know that everybody's looking for organic and natural. And we know that your product is organic. It doesn't get any more organic than that. So we're able to take this product and turn it into a highly absorbent compound. All right, and then this is just some of the wood that I've collected on my site. And as you can see here, we have the one on the far left over there. If any of you are familiar with Floyd Fest, which is a big festival that comes to Floyd every year, they've bought a new location. So they actually went in and tore down all their stages, and this was all heavy beams and a lot of different stages. There's some treated lumbers in their decks and all kinds of stuff. But they actually tore all that down and donated that to us. So we will be turning it into carbon. The center picture here you see is pulpwood. This pulpwood actually come out of a plant down in North Carolina where they make OSB. These are their rejects. And basically they debark the log, run it through a metal detector, and they claim that if it's a thumbtack in it, it kicks it out. So this is something that we had brought in from out of North Carolina. It's been debarked, and it's laying there drying out at this point. The other is just pallets. This is just people bringing pallets in and dropping them off. So this is some of the products that we will be using in the process. This is a basic setup. We are a batching system, and our systems looks a little bit like something out of space, sometimes satellites, they say, but these were some that we had just built and we were painting them. That's why you see some of the paint on the ground. But the picture there on the far left, you see is a basic drum, and this gets filled full of wood. The center section there is a complete system that's put together with a stack. And then on the right, you can see the stack there. This is the way it's a reburn system. This is the way we get rid of our emissions. And this technology is so good that when I applied for the DEQ permits, they give me an exemption. And what's amazing about this technology, we actually just finished testing in Arkansas. We just burned straight railroad ties, shredded them up, and we're burning off the creosote and everything. And so we sent that product for probably one of the most stringent areas that you can put carbon in is water filtration. So we took this product and shipped it to a big water filtration company. They said, send it all to them. It's pure product. So they were really excited about that. This is, we'll call this a kiln farm. We were coming up with sites. And as you can see here, the picture on the left, what you have there is basically, that's 10 stacks. That's one line for us. And what you see in the middle there, the silver things, those are, we call them bus stops. This is a PLC. All this is computer controlled. It's got temperature sensors in it. It's an algorithm that runs it. Everything sits there and basically does its thing. Takes us about 8 hours to run a batch through. What's interesting is we call it a conversion time. For whatever reason, if anybody can explain it to me, I'd like to know. But in Colorado, we're at 5,000 feet. It takes 11 hours to convert to carbon. I'm doing it on an average of 8, sometimes 7 hours. So we're able to convert a lot faster, which allows us to create more product. The center picture there again is just another setup. There's 10 stacks here. They'll all run at the same time. They'll run for about 8 hours. We'll transfer them over to the drum that you see sitting beside it. We'll run another. We're going to run 2 shifts, 16 hours a day. Each line there can produce in an 8-hour period about 6,000 pounds of carbon. And just to give you an idea, our carbon, we're $1 a pound. So it's about $6,000 every 8 hours that it'll produce in carbon thereabout. This is our processing facility that we're building. And the picture on the left, you can see a silo that's there. There's some collectors on top of the roof. Our dust collection system, it's not complete at this point. This has been a kind of a hold up. We tried to buy this equipment, but we're kind of pioneers in this area of processing. So we are actually building all this processing equipment ourselves. I've been fortunate to have a fabrication shop that's close by. So we've designed all this. We're building everything on site, and we're hopefully be up in the next month or so. We'll be up and operational. But you can see the one on the left, like I say, is just the building I built. Outside, we'll dump outside. There'll be a dumping system there beside the blue silo. It'll go into the building. Comes into the building. It actually come in on the picture on the right. Then the type of roller grinder. We're separating metals, any nails, any wood, any metal in the wood will be separated. Goes through a series of screeners. You can see the center picture there is the top screener. That's where it gets separated into 4 different sizes. All right, this is we do a lot of testing, and this is a basic, and I have a couple pieces of carbon with me if anybody would like to see them afterwards, but this is basically what the carbon looks like when it comes out of our kilns. It's just chunks of wood that we've heated at high temperatures. And what it's talking about here is the cation exchange. And due to the cation exchange, if you know anything about soils, cation exchange is basically the ability of a product to absorb something and hold on to it. So like in soils, we'll just say sand would have a real low. It's a 0 to 100 rating. So sand has about a 10 rating of being able to hold on to anything that goes into the soil because it just passes through it and leaches out and goes on. When you get up into more of your clays and your loamy soils and stuff like that, they'll go up to a 25 or so, which means it has the ability to hang on to water and different things a little bit better. And then if you get into your organic materials, it goes up to 100. And our carbon is up in the 90 to 100 range. And that means that it has the ability, when supplied into the soils, that has the ability to absorb water, nutrients, and all these different minerals that's in the ground, hold on to it, and allows it to be readily available for your plants and whatever else is growing around it. This is a little bit of a chart that we've done some studies. This basically shows the metals that we can bind up. This is in dirty water situations. We've done some testing. The Denver reservoir was just full of algae, which was a huge problem. So we actually just took some of the carbon, put it in some filter sacks, put it in the lake, in the reservoir, and let it float around. And within about a week, the algae was gone. So we absorbed up the nutrients, and you can see here the different things we can absorb up. A lot of it's 100%, we can absorb it. But once we bind that up and you pull it into the carbon, into the wood product, it just remains there. It's there from now on. And if it's in the ground, then your microbes and all your different fungi and stuff will clean it out, eat it, live off of it. It makes it readily available for the plants. Nutrients, this is kind of important for dirty water. Even though nutrients are good in our soils, one of the problems that we're having up in the Chesapeake Bay is the nitrate and phosphates that's leaching into the bay out of the chicken litter. And what's happening is it's toxic to the wildlife and the animal life, your fish and different things. And so that's what's killing the bay. So our product will absorb these up. The nice thing is it absorbs them up, and these are very important in our soils. So it does absorb it and hold it in the soil. So it's still readily available for anything that needs it there, but it doesn't allow it to leach away. There again, these are just some more of the solids that we can remove. There again, just being able to bind these products up. The carbon works sort of like a filter that holds on to things, but yet it's able for your microbes and different stuff that lives in the soil to come to it and be able to eat out of it and live out of it. And this therefore creates a much richer soil and a much richer environment for your plant life. We make 4 different sizes of biochar. We have a chip, which is this chip application is used, believe it or not, Bartley Tree Service is one of our big buyers. And they actually, when they're planting trees, they take these chips and they'll just put it right down in the root ball with the tree. So basically you're taking a tree to grow a tree is what it boils down to, but it allows it to absorb the water and maintain the water. The medium that we make here, this is water filtration. Working really good in water filtration today. And if any of you are familiar with the new PFAS chemicals, it's in everything. My wife and I were looking at some of it last night. It's just amazing that everything's in Teflon, it's in paper plates, it's everywhere. And this is a forever chemical that we have man produced. And now they're finding it in the water supplies. And the Smith Mountain Lake is full of it now. And our product will filter this product, which you have a lot of carbons, you know, I know like West Vaco, some of them, all of them, they make carbon. And you've got coal that make carbon out of, and all these are good products for filtering too, but they're not considered an organic product where we're completely organic. The small that we make, we've been testing this in concrete. We're testing Trex Decking is one of the companies that likes it in their product. The powder that we make here, the powder is used in multiple things. It can actually be put into a sprayer and sprayed onto your land, onto your plants. The other thing, the powder is we've got a contract right now with Saudi Arabia, and they want 81 million pounds of this powder in the next 2 years. And they're basically, what they're doing is there's a company out of Canada, and it's called Infusion Seed Ball, that they've developed. They take clay dirt and they make a ball, and they put in the carbon and they put in other nutrients, and then they'll put a seed in it, and then they'll close it up and they'll dry that ball. It's about like a golf ball. And what they're doing with that is then they're able to take that ball out and plant it. And basically they've used a lot of them in the mountains where the mountains burn. Just fly over the plane and throw them out. And now the seed ball is laying there. And when it rains on it, it will get wet, and that seed will sprout and grow a tree. And because of the carbon that's there, helps maintain the water and create microbes and gives an environment for things to live in, plus the nutrients. So you create a perfect environment for this tree to grow. So the Saudi Arabians, believe it or not, are running out of oil, and they don't have anything else. So they've actually, and what remains to be seen, they're spending a lot of money, but they're going to plant 10 billion trees. And they've learned that they can go in the desert, take this seed ball, plant this in the desert, and then, believe it or not, there's huge pockets of water under the desert. So they'll drill in and tap and be able to water their trees. And the theory is that they can grow these trees, which will create a shade canopy to cool the desert. Plus, trees create more rain. So therefore, they're trying to change their climate. So this is one of the projects that we've been working on that's finally got through. And it's kind of interesting, kind of exciting. And with the Floyd Fest group, they wanted to know where their carbon was going to go. And I told them probably Saudi Arabia. So they were pretty excited about that. But anyway, applications is water filtration, sanitation, composting, detoxification. This product, I'll actually eat it. We are medical grade carbon, and it goes through our pyrolysis process in the time that it takes. We cook everything out. Animal feed, we are USDA approved for animal feed. Okay, now what does feeding wood to animals do? I'll get into that a little bit more here in a few minutes. Waste management, we're working with some companies. Actually, I've been working with a company on sewage treatment to be able to treat the waters, carbon sink. So this is the big one in the environment today, is that carbon is running our ozone layer. And when a tree lays in the wood and it rots, it creates carbon. You're putting off carbon. Everything around us is putting off carbon. Well, it's amazing how that we can take this same carbon and create it, but lock the carbon in, and it actually absorbs carbon, doesn't allow it to weep out into the atmosphere, keeps it in the ground. And this is the big thing with environmentalists today, is that, we got to do something with that. And I think it's some of what maybe you guys are seeing in the wood industry about cutting down trees. But my whole thing is, if we can come to a common ground that we can take this product, your product, and basically your scrap products. I mean, I don't want your good logs. I want all that stuff to go to the market where it belongs. But if we can take your scrap products right down to your limbs, I mean, if you're logging and there's a dead tree there, get it. We take it. We love it. Anything, it doesn't matter, straight, crooked, whatever. We can take this product and turn it into something that we're sequestering carbon back into the atmosphere and keeping it here. So that should make them happy and makes you happy. And hopefully it's a good exchange. Soil amenities, there again, in the soil amenities, it can detoxify. It's a deodorizer. The deodorizer thing has just been amazing. I'll get into that a little bit more here in a minute. It's really good with fertilizers. You can blend it, helps maintain the nutrients. This is a picture here that we done, and this is a piece of wood. And you see the one on the left, it's magnified there 120 times. This is a piece of carbon. This is probably a piece of pine that was done. Pine seems to be more porous than poplar. We do like poplar, maple, pine. We can use oak. We can use basically anything depending on the market that we're going into. The softwoods like your poplar and your pines work really good in water filtration. But then there's other applications for the oaks and stuff like that. It seems like the oak and the hardwoods work really well in the ground. And then on the picture on the right here, you can see this is a piece of wood after we've pyrolyzed it. So basically what you see, we've opened up all of these cavities. And this is a negative ion product. All right. When we go through our process, we convert this piece of wood, normally would be a positive ion. We convert it into a negative ion product, which is, in simple terms, it becomes a negative magnet. So it's like static electricity. Nutrients, bacteria and things like that tend to be positive ions. So they're drawn to this. So what happens is it pulls it up into these pores and it just hangs on to it there. It's kind of interesting. You can take a handful of our medium carbon and it has the same surface area as a football field. And you think, well, how is that possible? Well, normally if I measure the surface area of this floor, I measure the top of it, and that's my surface area. Well, if you look at this here, when you measure surface area, you measure the inside of all those little pores, the outside of it. It's kind of like measuring a tube. You measure the outside and the inside, and that's your surface area. So it is interesting how it all works. All right, this is a project I'm going to just a little bit. This is I've been working on this for about 1.5 years or 2 years now. And I know that my product was really good in absorbing odors and nitrogen and phosphates and stuff like that. So we had, I'd been working trying to get in, and of course, you guys know if you go up into the Shenandoah Valley, there's 180 organic chicken houses there. So we were trying to get in. And so basically what you see here is wood shavings that they've put down, and they'll go in and put down a layer of wood shavings, which would be dry shavings. And they're usually, the barns are 25,000 square feet, and they'll run about 22,000 birds in there, and they put them in for 7 weeks. So I was finally able to get in with one of the organic growers, and they decided they wanted to try biochar or carbon in their bedding. So we took up 2 cubic yards of my medium, which is about 700 pounds of carbon. So when I showed up with this, two sackfuls of carbon, the guy kind of laughed at me, and he says, "Is that all you brought?" And I said, "Well, I'm giving it to you. I'm not going to give you any more. Let's try this." So anyway, it was kind of a little joke, I guess, with the guy. And they had my competitors around the country. They had brought some in and tried it. And so anyway, he puts it in the house, and all he done was took a fertilizer spreader, just a 3-point hitch fertilizer spreader on the back of the tractor. He spread it in the barn. And anyway, so he called me back the next week. He said, "Man," he said, "we didn't put down enough." He says, "It's just not working." And I said, "Well," I said, "our product is hydrophobic, which means it's not readily absorbs stuff right away. It takes a little bit to do it." And I said, "Let's give it some time." He called me back probably a week later. He said, "Man, I don't know what happened." He said, "I walked in the barn this morning." He said, "It's like the ammonia levels dropped big time." So 7 weeks pulled the birds out. And he called me up, and he said, "Hey man," he said, "I don't know what this stuff is, but it's amazing." He said, "I've never seen anything like it." He said, "I put this in my worst barn that I have here." And he said that when I pulled the birds out, he said, "I made $1,800 more off this house than any house I got up here." He said the birds were healthier. They weighed more when they left out there. They eat less feed, and the mortality rate dropped tremendously. So we backed up and looked at it, and I said, "Well, here's what we know's going on. As far as the ammonia rate, it was down 40%. We know we absorbed that ammonia and held it in there, which ammonia is a big thing with the chickens. Number 2 was the fact that they weighed more. Well, they're actually eating the carbon. They'll pick it out because it's black and shiny, and they think it's a bug. So they eat this carbon. Well, what happens with this carbon when it goes into the rumen, into their stomach? Now it absorbs bacteria. Well, bacteria eats nutrients. So therefore, now the chicken is able to get more nutrient out of the food that they're eating. Therefore, they eat less feed, because it's just like us. If you eat really healthy, good food for you, you don't get as hungry as fast, because you're able to absorb more of the nutrients in your body. So that was the reason for them being able to grow more, way more with less feed. And then the other thing was the ammonia rate down. The other 2 houses he was pulling between 25 and 50 chickens a day the last week, which is pretty typical. This house with the carbon in, he was pulling 5 or 6 a day. So that was where he profited more. So it's really interesting that we can take your product, a wood product, turn it into something, and it's just beneficial all the way around. But this is just some more pictures of the carbon, and you can actually see where the screw is laying. Right at the tip of the screw is a piece of our carbon, which you can see some little pieces laying in there, but that's actually in the bedding. And this is actually the 3rd flock of birds that's been through this on this carbon, and it's still working. But look how dry it is. It absorbs the moisture. And if you know anything about chickens, if you get a lot of ammonias in the bedding, it'll burn their feet. So this is real important that it's dry. Okay. That's all I have, but I guess kind of where does this come to you guys? So right now we're starting out, and I'm using about 20,000 tons of wood per year right now, starting out, which is not a lot of y'all. We will ramp up next year and be taking in more. So this is a business that is growing. We have places all over the U.S. that we're putting up. This is a market for your products. There's carbon credits involved. You can have the availability to receive carbon credits. If any of you are keeping up with that market, that's big. So I'm excited because I grew up in the wood industry. My dad and my uncle owned a sawmill. Now, it was the old ratchet mill. And that's my uncle that used to run it, called it the money stick. You guys know what the money stick was. So I did grow up around that. And so, you know, I'm excited about it for the Appalachians and for everywhere. And it's amazing that we can take your scrap products, and even in the CLT they're talking about, any chunks of wood that you have, the cutoffs, the glues, anything and all that, it doesn't matter to us. We cook all that out of it. So we're excited about where this is going. And, you know, I think the future is really bright. So I really think in the near future, and I mean near future, this is going to be a really good market for the industry. So that's all I had.
Real quick, that was probably a longer explanation than you would give right now, but in that reburn process, how is that not always hard?
In that we run the temperatures that we run, we burn it off. Yeah, it's without going on all the technical details of it, stuff I really can't share. It's basically a refractor. It's nothing complicated about it, but we run about 1,650 degrees on this stack. We don't have any smoke unless we cut the stack off. But basically, it's a reburn system that we reintroduce the wood gases that comes out of our product. We reintroduce it back to high temperatures and oxygen. It just burns it up, disintegrates it. Now, to say there is absolutely zero coming out of there, no. But just to give you an idea, DEQ said I could burn 55 of these stacks, 24 hours a day, 7 days a week, 365 a year, and not meet the threshold for what they would call pollutant. So yeah, so it's just really nice technology.
It's an amazing process. I had devoted about 30 or 45 minutes to my visit when I met with him a couple of months ago, and I think I was there 3 hours. So it's an amazing thing that they're doing there, an opportunity to expand. I don't know, you didn't talk about that any, but I think there's other companies or partners that you're looking at to expand across Virginia.
Yeah, right now our goal is we're looking at one in Broadway, Virginia right now. We've got one up in Manassas, Virginia. We're back out toward Tazewell. We're looking at some sites. The goal is to have 10 more of these sites up in the next 5 years. One other thing I'll throw out there too is we did, for this whole project, we didn't get any grants. I'm fortunate that I partnered with my partner Floyd that has money to do this. But another thing that I think you guys need to know about too is the USDA put out a fertilizer expansion program here last year. There's like $900 million in it. I did apply for that grant, never done it in my life before, had no idea. It kind of took me about 2 months to put it together. We did apply for it to start composting because some of our product we can't use. And in that product, I will need chips and sawdust. So that is another, I can't really use chips and sawdust in my process because they're too fine. I like bigger chunks of wood. But the composting thing is another thing that's really starting to take off. And the USDA is starting to see the need for more of a domestic fertilizer product, and they're focusing more on the regenerative type of farming and using the products that we have. So we did receive that grant. It's a $6 million project, and we got $3.7 million to start this project. So I'm pretty excited about that. So there again, that's another market that we're developing, and that will take. I just, in my project narrative, I told them 25,000 tons of compost the first year. And then we would just keep adding, expanding from that. So that is another huge market for your sawdust and your chips that's coming along.
Okay, great. Any other questions? Yes, Renee?
About putting the carbon in the water,
Uh-huh.
the carbon in the water to remove the algae. When you remove the chemicals like that, or for that case, the algae, what do you do with the carbon once it has taken something out of it? How do you dispose of that?
Well, it depends. Like in the algae, what happens with algae is algae is a living organism. So it lives off nutrients in the water. Well, what happens is when we put, it's pretty amazing. You put the algae, put the carbon in the water, and it absorbs the nutrients that's in the water. So therefore, algae just dies because there's nothing for it to live off of. Now, what's important about those nutrients is they're very good for soil. So you can actually pull that back out. If you're not absorbing any toxins, you can pull that back out and put it right in your garden or whatever you want to do with it. Technically, here's the neat thing about it is in water, because when I got into all this, my partner, I said, okay, if I've got a guy that's got like an open water box. We use it a lot in open water boxes for cattle that have a lot of algae in them. I said, how often do I tell him he's got to change his? He said, well, from a sales point of view, every 6 months. He said, but technically never. And the neat thing is what happens is microbes, if you know anything about microbes, we're full of them, everything, and they're amazing little microbe here. Well, what happens when it's in the water and it absorbs the nutrients live off of that. The microbes live off nutrients. They go inside of those straws you've seen and they actually eat it and clean it. So the carbon, believe it or not, is a self-cleaning filter that seems to last forever. Now, in the reverse side of that, in the PFAS world, where we're absorbing Gen X is what we're trying to absorb now. That is a problem. I know Calgon uses, they say they acid wash theirs to clean it, to reuse it. I have not got them to tell me what to do with the acid after they do it. So what we're working on right now, and we're 99.9% sure we can actually put it back into our kilns and reburn it and destroy it and get rid of it. So that's one way you can get rid of it. But that is a good question, you know. So, but, and we haven't got through the studies on it now, but we really believe, and we're ongoing with it. We really believe once this carbon absorbs that Gen X, it doesn't release it anymore. It just like sits there. So I don't know what, you know, other than burning it up. But we've tested it. We've thought about trying it in concrete products because we're right now, our carbon is going concrete, asphalt, plastics. The automotive industry is eating this thing up for plastics. I mean, it's just all over. Basically anything you can think of, the carbon can be put in it. And just to give y'all a real quick thing of, I think it's exciting. And if this develops, and it looks like it's going to, there again, it's just a huge market for the wood industry, is battery technology. And we all know with electric vehicles and everything that's out today, and with the battery technology is moving forward. And so Elon Musk is actually working with us, and he's got some plans for it. We have a company out of Thailand that says they've developed a battery that they can use our carbon in to make an organic battery. And we got another company in the upper part of the US. If you know anything about batteries, like lead batteries, you have contactors in there. Well, the contactors will burn up, and that's what shorts your battery out. Well, they have took our powder and coated those contactors, kind of like graphite, and they found that now that battery's lasting 10 or 15 years because the carbon keeps it from burning the contactors up. So there's a lot of exciting stuff going on with the products you're making out there.
So several of us at NHLA live in a particular suburb outside of Memphis, and our water supply has been contaminated by diesel fuel since last week. It's undrinkable. They say don't use it for anything but flushing. Would you have 2 bags of this on you that I could throw in the trunk when we?
No, but we can get you some.
I didn't shower until I got to West Virginia. So
that's another thing that you mentioned, the diesel fuel that we're testing with is, you know, everybody that runs any equipment know you get, well, they call it algae in your diesel fuel, and it's where they took the sulfur. It's not actually an algae. It's I forget what they exactly call, but I've actually got a manufacturer that's testing our carbon to make a filter that would drop down into your tank that would absorb that to get rid of that out of your diesel fuel. So we'll see where that goes.
Great. Thank you.